Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for real functions. In the previous session, we have already discussed about functions and the related terminologies like domain, codomain and range. Right? In this session, even in the previous session, we have discussed vertical line test to see whether a given relation is a function or not. In this session, we'll be taking some examples and will try to find out whether the given relations are functions or not. So let's begin this session now. Now friends, suppose I have this example over here. Let X is this set, Y is this set. Find whether the rule F given by Y is equal to X square is a function from X to Y or not. First of all, I draw a diagram to show the relationship. Wait a moment. Now here it is given that y is equal to x square. The elements in x 1, minus 1, 2, 3 and minus 1, minus 3. 1, minus 1, 2, 3 and minus 3. Right? Elements in y 1, 4, 9, 10 and 11. Now y is equal to x square. Square of 1 is 1. Square of minus 1 is 1. Square of 2 is 4. Square of 3 is 9. Square of minus 3 is 9. That means 1 is image of 1 and minus 1 both. 4 is image of 2. 9 is image of 3 and 9 is also image of minus 3. Right? Now we have to see whether it is a function or not. Now there are two conditions. First of all, every element of this set should have an image in the set B. So we can see that every element is having an image. Right? 1, 1, minus 1, 1, 2, 4, 3, 9, minus 3, 9. Right? After that, the second condition is each and every element should have a unique image. Right? That means no element in the set A can have two images or more than two images in set B. Right? So we can see 1 is associated with 1 only, minus 1 is associated with 1 only, 2 is associated with 4 only, 3 is associated with 9 only, minus 3 is associated with 9 only. That means each element of set A has an image in set B and each element in set A has a unique image in set B. That means it is a function. Right? Now if we talk about codomain, see codomain will be 1, 4, 9, 10 and 11. The entire set. Right? But range will be what? Only the elements which are having pre-images. Right? So here 1, 4 and 9. These three elements are having pre-images. Pre-image of 1 is 1 and minus 1. Pre-image of 4 is 2. Pre-image of 9 is 3 and minus 3. 10 and 11 they don't have any pre-images, so they won't be part of range. Right? So domain is 1, minus 1, 2, 3 and minus 3. Codomain is 1, 4, 9, 10 and 11 and range is 1, 4, 9 and this is a function. Right? So I hope now you are clear with the definition of function. I take few more examples. Now in this question, x is this, y is this. Find whether the rule f given by y is equal to 2x a function from x to y or not. First of all, I draw the diagram. Wait a moment. Now see here, x is 1, minus 1, 2 and 3. Y is 2, minus 2, 4 and 6. Now y is equal to 2x. That means this is x. So y must be 2. That is 2x. Here minus 2, 4 and 6. Right? Now image of 1 is what? 2. Image of minus 1 will be minus 2. If x is minus 1, y will be minus 2. Image of 2 is 4. Image of 3 is 6. Now we have to check whether it is a function or not. Again, the two tests we have to do. All the images of set A are having images in set B, right? Apart from that, each element of A is having a unique image in set B, right? 1 is mapped with 2 only, minus 1 is mapped with minus 2 only, 2 is mapped with 4 only, 3 is mapped with 6 only, right? So this will be a function. Okay, now here in this function, what will be the domain? It's a function first of all. What will be the domain? 1, minus 1, 2 and 3. So this is domain. What will be codomain? Here it will be 2, minus 2, 4 and 6. So this is codomain. Now here in this case, you can see that all the elements in set B are having pre-images, right? 2, minus 2, 4 and 6, all the 4 elements, right? So for this particular set, codomain and range will be same. So what will be the range of this function? That is 2, minus 2, 4 and 6. Okay, so I have discussed domain, codomain and range, all the 3 for this particular function. Okay. Now friends, I just take some random examples over here and let's check whether the given relations are function or not. Suppose f such that it is defined from n to r and fx is equal to x square. Now what is happening over here? Domain is natural numbers and codomain is real numbers, right? That means this is a circle of natural numbers. This is the circle of real numbers. Right? Now, in this set, we are having all the numbers, all the natural numbers, that means from 1 to infinity. And in this set, we are having all the real numbers. Now, what is happening over here? What will be the image of 1, 2, 3? Image of 1 will be 1, image of 2 will be 4, image of 3 will be 9, and similarly, the series will go on. Now, whether it is a function or not, that we have to check. So, see, every element of set this n is having image in this set R, right? Because 1 is mapped with 1, 2 is mapped with 4, 3 is mapped with 9, right? And every element of set n will have a unique image in set R, because 1 can be mapped with 1 only, 2 can be mapped with 4 only, 3 can be mapped with 9 only, right? That means it is a function, right? Now suppose and the domain will be what? Well, natural numbers. The codomain will be real numbers, but the range will be 149. We can say range, I just write over here, square of natural numbers, that is 149, this. Okay, so codomain will be real numbers, domain will be natural numbers, but the range will be 149 till infinity. That means the square of natural number precisely, right? Now instead of that, suppose I take f such that z to n. Just a moment. Now our function is defined from z to n. That means this is the set of integers. Over here we'll be having minus 1, minus 2, 0, 1, 2 and the entire series. This is z and this is n. 1, 2, 3, 4. And the relation which is given to us as fx is equal to x square. Now we have to find out whether the given relation is a function or not. Now friends, to be function, we have to show that every element of this set is having an image in this set. Now minus 1, the square of minus 1 will be 1, square of minus 2 will be 4, that will be there in the set of natural numbers, square of 1 will be there, square of 2 will be there. Each and every element of z will have an image in this set except one number, that is 0. Right? Square of 0 will be 0 only, and that is not the part of natural number. Getting my point? It is not an element of natural number. So 0 won't have any image in this set. That means the given relation is not a function. Right? Instead, it would have been f such that z to z. That means this is also set of integer, this is also set of integers. In that case it will be an integer, because in that case even 0 will be having an image, because in this circle 0 will be there, -1, -2, all the negative integers will be there, positive integers will be there, as well as 0 will be there, right, for this particular relation I'm talking about. So in that case f such that z to z, it will be a function, because every element of this set will have an image in this set, and that image will be unique, right? -1 will be associated with 1, 1 will be associated with 1, right? So domain will be z, codomain will be z, but what will be range? It's 0, 1, 4, 9. Okay, because negative elements will not be part of range, because square of any number cannot be negative if they are real, right? Now similarly, if we have a relation r to z for fx is equal to, say, x, just fx is equal to x. Now whether it will be a function or not, it won't be a function. You don't have to draw even Venn diagrams. It won't be a function because domain is R, right? Suppose for better explanation I do it -1, -1 by 2, 3 by 2, whatever, -3 by 2, 0. So each and every element of this should have an image over here, but this is the set of integers. So -1, f of -1 will be -1, but f of -1 by 2 will be also -1 by 2, right? And that won't be an element in the set of integers, right? So this is not a function. Instead, if it is z to r, then it will be a function, because all the integers, f of -1 will be -1, f of -2 will be -2, f of 0 will be 0, and all of them are part of real numbers, right? So in this case it is a function, but this is not the function. Now I'm sure you'll be clear with the definition of function. We have taken so many examples. Okay, now friends, let's discuss domain, codomain and range in detail. Domain: if a function f is defined from a set of A to set B, then f A to B set A is called the domain of the function f. Or we can say all possible values of x for which fx exists. This is the domain. This is the complete circle is codomain, and range is the subset of codomain, right? Here A, B, C, D, this is domain. P, Q, R, S is codomain. All the elements of set P will be part of codomain, but the range will be P, Q and R only, right? Domain is ABCD, that is set A. Codomain is PQRS, that is set B, but the range will be PQR because S doesn't have any pre-image in set A, right? Or we can say S is not at all occupied, right? So it won't be part of range. Okay. Now friends, frequently a question based on domain is asked in various competitive exams. Even in your board exams it may be asked, right? So there are certain rules how to find a domain of a given function. So let's have a quick glance over there on the rules by which we can find out the domain of a given real function. Here we are just discussing the rule. Practically we'll see when we'll be solving the problems. So do not try to mug up the rules. You just have to keep the rules in your mind. So while calculating domain, it will be easier for you, right? Expression under even root cannot be negative. That we know. For a real number or a real expression, the term under square root should not be negative, right? Denominator cannot be 0. Otherwise it will be a non-defined term. Domain of y is equal to fx and y is equal to gx are, we assume them to be d1 and d2. Then domain of fx plus minus gx or fx into gx is the intersection of d1 and d2. We'll practically see it, not to worry much. Domain of fx by gx is d1 intersection d2, and we have to take care that gx is not equal to 0, right? So whenever gx is equal to 0, we need to deduct those cases, okay, from d1 intersection d2, right? For y is equal to fx, domain of f x such that fx is a real number. Okay, so these are some rules which we'll be using to find out the domain of a given function. So friends, in the next session, we'll be discussing the methods to find out the domain of a given function. Do revise this session and the previous ones so you'll feel comfortable in the next session. Okay, I'll see you in the next session once again. Bye bye.